All right, now we see Wakata bringing in the safer device that's going to get attached to Josh Cassada's suit. Now, we're going to see these two go out of the airlock, and then they're going to kind of go their separate ways at first before meeting back up for the install. So Josh Cassada is going to be getting into the APFR, the Articulating Portable Foot Restraint, on the space station's robotic arm, the Canadarm2. And back inside of the station, Nicole Mann's going to be what's called the M1. She's going to be the primary robotics controller, essentially, for this spacewalk, and she's going to be literally flying Cassada as he's at the tip of that arm to the different work sites. And so Cassada and Rubio are going to meet back up over at the FSE, the Flight Support Equipment. That's the temporary stow location right now for the last iROSA array that just arrived on a SpaceX Cargo Dragon. And they're going to work to release some of the beams that are in place to help keep it secure during launch and all of the movement operations. They'll remove those beams, and then they'll release the actual array itself from iROSA. And then after that, flying on the end of the robotic arm, Josh Cassada is going to get moved over to that work site, bringing the array with him. And then once they're there, they'll get into the actual installation steps, and that'll involve, as we saw through some of those graphics, actually unfolding the array into its configuration where it could be installed. First thing they'll do is essentially get it soft captured. It'll slide into place, and there's some soft capture mechanisms that put that initial hold on the array, and then there's a number of bolts that they'll drive to secure it in place. And then after that's done, they tension some of the mid joints to make sure that it stays unfolded, and then we actually step into deploying, or first we actually will mate the cables that are responsible for integrating that array.
Tie down with 3 turns. Can I release my right cable?
And Koichi, we copy. We think we'll need to get...
and Frank, you need to have 2 wire ties with 3 twists holding down the cable to release your red. So we need you to put it under that next wire tie.
Okay.
Okay, copy that. Thank you.
Okay, Nick, let's talk about an ARD. I see AR3 here at C12.
Okay, copy that. And so you'll attach your adjustable from your trash bag to that ARD tether point, and then when you're ready, I've got PGT settings for you.
That's great.
And just a reminder, that tether point is not the long lanyard, it's the physical metal tether point.
Thank you. Okay, I've got my adjustable on it, and that adjustable is ready back to my mini workstation, and I will go for my PGT.
Copy, Josh.
And then Nick, well, I guess we'll see. I was going to ask if that tab's going to move out of the way. I need to reach in there and persuade it, but I think it might want to go once we go counterclockwise a little bit.
Yep, you're thinking the same thing that I am. There's no spring loading or anything, so when you loosen it up, if it doesn't rotate out of its way, you may have to nudge it.
That's good. Okay, we are woken up and calibrated.
Copy, Josh. So it's going to be Bravo 3.
Okay, here comes the motion in 3, 2, 1, starting the motion. Okay, Josh, we are ramping out.
Okay. Copy that, thank you. Hey, Josh. Hi, Frank.
And Frank, I see you in a good position there on the left side.
Yep, and I can verify all face-off captures are still in a good position.
Okay, Josh, arms in position hold. We're going to set up for manual for iROSA install.
Copy.
And Frank, the same cautions and warnings apply that I've previously read, plus a couple here. So the warning is don't put finger in the iROSA pin slots on the inside and outside of the root beam. And then when on the aft side of the mod kit, avoid contacting the legacy blanket boxes and trunnions.
Okay, copy all. Thank you.
Yep, and then you've got the cautions about mod kit. Don't simultaneously impart loads, translate slow, and a max load of 30 pounds.
Copy.
Okay, Josh and Frank, we are ready for the manual maneuver to the iROSA install position. This is per your GCA, Frank, to the published position, which is body left 2.2 meters. Are you ready?
Okay, I am ready. Yeah, and you have just to verify, this is a GCA to publish, correct?
You published, which is body left 2.2 meters for Josh.
Okay. You have a go?
Okay, here comes the motion in 3, 2, 1, arms in motion.
See motion, good motion.
Okay, good motion. Another 1.5 meters to go.
Still clear, continue. Copy.
And with Josh and iROSA arriving out at the worksite, we're maneuvering it into the install position. So there's going to be two soft capture.
1 meter to go.
Copy, still clear, continue.
Two soft capture devices that are going to lock in on this first part of iROSA. And after those are engaged, we'll be able to get Josh Cassada out of the robotic arm to move around to begin getting ready for the unfolding of the array, after which they'll engage the third and final soft capture.
$50 to go.
Copy, continue.
Continue.
So the array continuing to unfurl the view that Josh Cassada is getting right now as it unfurls away from him after he released those two launch restraint bolts.
You can see air traffic. Yeah, there's a contrail. There. Yeah, I see it.
And that view from Frank Rubio's, if you look at the booms on the side, you can see they kind of curl up after they continue to deploy. This is a look at the very far end. You can see all of the solar cells in the middle there, and those booms as they continue to stretch out, they essentially snap together into that circular structure, and then they have magnets that are helping to help them maintain that structure once they snap in.
And Frank, Josh, while we hold position and wait for the deployment to finish, just kind of give you a heads up on the way forward, at least near-term steps. We've got the tensioner bolts that we're going to do, and then we'll move into kind of cleaning up the scoop and the cable bag, and then we'll focus on trying to get the arm clean and FSC in a good config.
Okay, sounds great. Copy that.
We're continuing to watch as these unfurl. Again, as you can see, they're covering up some of the solar cells on the existing arrays, which are still tied in to the power channel. But these new ones coming in with a higher efficiency, obviously brand new, so haven't lost any of that efficiency that you lose over time and being exposed to that harsh environment of space. We're going to be able to increase our actual power output. So we're aiming to have 6 of these total eventually deployed on the International Space Station, this rollout solar array technology. We did an initial test of this type of array several years ago on the space station, just to see how the mechanisms worked, how the power generation worked, and then ultimately culminating in some permanent additions to the station. This same type of rollout solar array technology used on the NASA DART mission, which was our asteroid redirect.
It's that storm. Yeah, it's crazy how big it is. Affecting the entire country.
And we are passing.
Coming up on the Pacific Northwest.
Okay.
Just about to pass over the Pacific Northwest, and as any of our viewers in America are aware, there's some pretty significant winter weather hitting a lot of the country, so our crew members getting a view from about 260 statute miles above. While this rollout solar array almost done deploying, we'll note the same type of solar array, this rollout technology, going to be used on NASA's Gateway station around the moon as well. That's going to be our launching point for the Artemis program and future lunar landings, eventually establishing that sustainable lunar presence on the moon. So our crew members continuing to stand by, observing the rollout after this deployment sequence is complete. We'll have a couple of final steps. For Josh Cassada, he's going to have 2 blanket tensioner bolts that he is going to release. These essentially activate a spring that it's going to pull on some internal wire to the solar array itself to add some tension, which will be necessary as we're maneuvering and gimbaling the solar arrays, as we always try to point them to track the sun.
Look at the mountain. Also all right? Yeah, it's coming right meter right now. Between, I don't know if you can see between the two solar arrays. Wow. That is a lot of snow. I think it's Sierra Nevada, I'm guessing.
Okay, guys, we have confirmed we've got a good deployment on iROSA. So, Josh, you're go to move into position to do the tensioner bolts R11 and 12.
Copy that.
And for both of you, I've got a handover in 15 seconds.
Copy that.
And just a short handover, we'll get that video signal back as the crew now stepping into some of the final steps of the day, as they're going to work to now release 2 blanket tensioner bolts. Josh Cassada using his pistol grip tool to make that happen. Those are going to trigger some springs that are going to pull on some tensioning wire in the arrays to add some structural rigidity to this now fully deployed solar array. After that, we'll get into some worksite cleanup, likely get another glove, hat, and gauntlet check.